Hello, algebra students. I want to give a special shout out to Derek Katrubes and to Maggie Rafe and Aaron Waters and Bailey Leonard. And I'm learning some of your names, and I've been impressed with some of the work you've been doing. You're trying your best. Oh, I'm sorry, excuse me. I shouldn't use the T word. You're doing your best and you're learning. Hopefully you're still watching these videos. Anyway, I'll say hi to more of you as the year goes on. I get to know you better. It's only been a couple of days. So give me a little time here. Today we're going to talk about adding and subtracting fractions with unlike denominators. I think I stopped the last video with like denominators. And then we're going to multiply and divide fractions, which I think is easier. And then we'll also do some solving of two-step equations. And I will get to the graphing in tomorrow's video. Anyway, this is the video for August 20th. Okay. I believe I'm going to go ahead and give you the test on Friday just because we want to make sure we go over all this material, and I think some of you really care and want to do your best. But you have some gaps in your learning, and we're working hard to close those gaps. So anyway, let's get on with it so I don't waste too much of your time. There won't be any special guest appearances in this video except for my friend, never mind. Okay, so we've got problem A here is 1/5 plus 3/4. Now, you remember in the last video, I showed you how simple it was to add fractions when the denominators are the same. Problem is with this, we don't have like terms. We want them both to be fifths or both to be fourths or in maybe some other denominator. Now, we can't turn them both into fifths or fourths, but we can turn them both into 20ths. Why did I get 20? 20 is the least common multiple of 4 and 5. It's the smallest number that 4 and 5 both go into. So, how do I turn 5 into 20? Well, I multiply it by 4. But if I multiply the 5 by 4, I've just changed the fraction. It turns into 1/20th. 1/20th and 1/5 are not the same fraction. But watch this. If I multiply the numerator also by 4, I don't change the fraction, I only change the way it looks, and I'll prove it to you. Hold on, where's my shade? Shade, where are you? I found it. Okay, what's 4 divided by 4? Well, of course, it's 1. What happens when you multiply any number by 1? It stays the same, right? So I'm not going to multiply by just anything. I'm going to multiply by a special form of 1. A form of 1 that will give me a 20 in the denominator, but won't change the value of my fraction. So now I multiply 4 times 1, and I get 4. And I get 4 times 5, which is 20. So you see, 1/5 is the same fraction as 4/20ths. If you divide them, you'll get 2/10ths in both cases. But I changed the way the 1/5 looks, and you'll see why I did that in a minute. All right, now I've got to turn this denominator here, into a 20. So I'm going to multiply by 5. But again, if I do it in the denominator, I'm going to do it in the numerator. And now I'm going to end up with 15/20ths. Now, if you notice, both denominators are the same. I've got 4/20ths, 15 more 20ths. How many 20ths do I have? I have 19/20ths. See how simple that is? It's all this trick about multiplying by a very special form of 1. All you have to do is find the least common multiple of the denominators and then multiply so that you can change the old denominator into the least common multiple. You do the same number in the numerator. All right, let's try it in this one. It works for subtraction also. See, the least common multiple of 7 and 3 is 21. It won't always be the product of those two. I'll do an example C in a minute where it's not. All right. So how do I turn 7 into 21? Well, I multiply by 3, and I multiply by 3 in the numerator. Look, there's that special form of 1 right there. So I'm going to get 18/21ths. For the denominator, for the 2/3, I'm going to multiply by 7/7. And I'm going to get 14/21ths. So if I have 18/21ths, and I take away 14 of them, I must be left with 4/21ths. Easy as pie, guys. This stuff is cake. I know you used to think fractions are hard. Hopefully, they're getting easier for you. Okay, now let's say I had one like this. Let's say I had 3/4 plus let me see here. Let's go with 5 Let's go with 7/10. Okay. The least common multiple of my denominator is not 40. Okay, if you want to know how to get the least common multiple, pick the bigger denominator and count by it until you get a number the other denominator goes into. All right, so the bigger the two denominators is 10. So I'm going to count by 10, 20. Stop! Why do I want you to stop there? Because 4 goes into 20 evenly. There's my least common multiple. Yeah, it's that simple. So to multiply the 4 by 5, but I'll have to multiply the 3 by 5, 3/4 is the same as 15/20. Now over here on the 7/10, I'm going to multiply by 2/2. And that'll get me 14/20. How many 20ths do I have? Well, I have 29 20ths. By the way, this is an acceptable answer as long as it's simplified. That improper fraction is simplified. I know in elementary school a teacher might have told you, never give an improper fraction. They're incorrect. They didn't know any better. It's okay. There are some situations when you're going to want an improper fraction over a mixed number or something like that. If you want to turn it into a mixed number, that's okay too. How many times is 20 going to 29? Once. It's 9 short. And what did I divide by? 20. And there you go. Either one of those answers is acceptable. I would not go to a calculator on this. All right, we're going to get some practice with that tomorrow in class. All right, multiplying fractions is easier because you don't need a common denominator. You can just multiply. Now, right here in this problem, I'm just going to multiply 2 times 3 and 5 times 4. And I'm going to get 6/20. Okay? Now, I have to simplify the 6/20. I see that 6 can be thought of as 3 times 2, and 20 can be thought of, as 10 times 2. And remember before my example of, a special form of 1? Well, look at this. Do you see 2 divided by 2? I sure do. 2 divided by 2's will cancel out, and therefore I'll be left with the fraction 3/10. Now I'm going to do that problem again because I could have done it another way. You may want to take some notes on this because it's pretty slick stuff. All right. I like to simplify my fractions before I multiply. I look down the first fraction and see if 2/5 can simplify. In this case, it can't. I look down this fraction, 3/4, to see if it can simplify. And no, it cannot. But what you may not realize, because of the commutative property, I can simplify diagonally in both directions. Now, 3/5 won't simplify, but 2/4 will. 2/4 is the same as 1/2. Now, if you're wondering why that works, 2/5 times 3/4 is the same as 2 times 3 over 5 times 4. And because of the commutative property, I can say it's the same as 2 times 3 over 4 times 5, and therefore it's the same problem as 2/4 times 3/5. And look at that, that 2/4 is the same as 1/2. So that's all I'm doing without doing all of that work. Okay, so remind me to show you, tell you about Wonder Woman tomorrow. So my new problem is 1/5 times 3/2. And I'll do 1 times 3 and get 3, 5 times 2 and get 10. Now some of you are thinking, I'm not going to do all that work. That's a lot more work. Actually, it's easier if you simplify first. Let's drop down to this one here, 6/7 times 8/12. Now this won't simplify. However, this will. 8 and 12 can both be divided by 4. And so if I divide by 4, I get 2. And if I divide by 4, I get 3. Okay? Now I'm going to check diagonally. 6 and 3 can simplify. 6/3 is the same as 2/1. Now I can't simplify this way because that's not division. Nothing's going to simplify here with the 2 and the 7. So my new problem is 2/7 times 2/1. I'm ready to multiply. 2 times 2 is 4. 7 times 1 is 7. My answer is 4 sevenths. Division is handled the same way, except you need to multiply by the reciprocal. Okay, now in this case, nothing will simplify, but notice this changed to multiplication, and I use the reciprocal. Some kids call it the refliprical to remember what a reciprocal is, meaning the 1/3 becomes 3 over 1. I'm ready to multiply. I get 15 over 8. I can give that as an answer, or I could say 1 7/8. 8 goes into 15 once. It's 7 short. I divided by 8. So this problem here is really 3/4 times 2 over 1. Now I do see some simplification I can do, not vertically on the left side, not vertically on the right, diagonally this way. 2/4 is the same as 1/2. And so I really have the problem 3 over 2 times 1 over 1, which is 3 over 2. Again, 3 over 2 or 3/2 is an acceptable answer. If you wanted to, you could do this. Okay, let's see. Let's move on down here. We're going to do some solving of two-step equations. And when you solve two-step equations, you need to listen to Saddam. Listen to Saddam. Listen to Saddam. Saddam tells you how to undo problems. You're going to undo subtraction and addition before you undo division and multiplication. All right, so I look at this problem here, 3x plus 5 equals 20. I ask myself, what is my goal? It's to get x alone. What numbers are keeping the x from being alone? The 3 and the 5. How is the 3 attached? Well, it's attached by multiplication. 3x means 3 times x. How is the 5 attached? By addition. According to Saddam, I'm going to get rid of the 5 first because it's attached by addition. How do I undo addition? I use the inverse operation. I subtract, but I must do it to both sides. And so I will get 3x equals 15, and then I've got to undo this multiplication. Well, I undo multiplication by dividing. And so I get x equals 5. And there you go. Now I'm going to check my answer. I'm going to go 3 times 5 plus 5. 3 times 5 is 15, plus 5 is 20. It checks because I got the 20. Let's try this one. How is the negative 2 attached to x? Well, by multiplication, right? How is the 7 attached? Be careful. This negative belongs to the 2, not to the 7. It's actually attached by addition. Why? Because it's a positive 7. Saddam tells me to get rid of the addition before I get rid of the multiplication. So I'm going to get rid of the 7. Well, how do I get rid of a positive 7? I use the inverse. So my equation now becomes negative 2x equals 8. And then I need to divide by negative 2 on both sides. So x is going to equal negative 4. Now, of course, I'm going to check my work. 7 minus 2 times negative 4 equals, well, I'm going to do my order of operations. I'm going to be careful here because that negative on the 2 belongs to the 2. So I really have the problem negative 2 times negative 4. So I have a 7, and a negative 2 times a negative 4 is a positive 8, and 7 plus 8 is 15, and there you go, it checks. All right, 2 more examples, and we'll call it quits on this video. All right, here I have a 4 attached by division, right? A fraction bar means division. I hope you realize that. And a 1 attached by subtraction. Well, according to Saddam, I will undo subtraction before I undo division. So how do I undo subtraction? I use the inverse operation. And so now I have x over 4 equals 6. Now I have to undo division. Well, I'm going to use multiplication. But I'm not going to multiply the 4. I'm going to multiply the x over 4. So I'm going to put the 4 in the numerator. I don't need a fraction on the right-hand side because there isn't a fraction in blue there. There's just a 6. When I do this, the 4's cancel, leaving me with an x over 1, or just simply x, and 6 times 4 is 24. Now, of course, we can check this. 24 over 4, over 4 minus 1. 24 divided by 4 is 6, minus 1 is 5. It checks. Yay for me. All right, one more. Here, I've got a positive 4. I've got a negative x over 3. Well, this 3 is attached by division. You could think of it as a negative 3 if you want. You could go like that. I don't do it that way, but there's nothing wrong with it. Where's my back arrow? Okay. And the 4 attached by addition. Well, I'm going to undo the addition first, like so. I'm going to get negative x over 3 equals 1. Now, to get rid of this division, I'm actually going to multiply by a negative 3 over 1 times a negative 3 on that side. Just so I don't create an extra step. If I multiply by a positive 3, the negative will still be there, and I'll have to do one more step. I'll have to multiply by a negative 1 or divide by a negative 1. So here, the 3's cancel, the negatives cancel, I'm left with an x. 1 times negative 3, negative 3. Let's try it. 4 minus negative 3 over 3 equals 5. 4 minus, right here will become negative 1, minus a negative is the same as adding a positive. Think about it this way. Do you have a bad habit? I don't know, maybe some of you bite your nails. Maybe you crack your knuckles. Maybe you pick your nose. Don't tell me too much information. All right, if you have a bad habit, that's a negative thing, right? And if you take away the bad habit, isn't that a positive? You take away a negative thing. Let's use the example of smoking. Somebody smokes. Of course, we're going to assume they're an adult. That's a really bad habit. It's a health risk, etc., etc. It's a negative thing. Well, if they stop smoking, they take away that negative habit. Now their lungs will recover. They can live a healthier life. So you take away the negative, you get a positive. So 4 minus negative 1 is the same as 4 plus 1. And that is, of course, 5, and that's what we wanted it to equal. There we go. All right, that's it for tonight's video. Mr. Lawrence signing off. Have a good night, everybody.